Hey everybody, welcome to section 4.2, guided notes. This is the slope of the line. So your I can statements today are going to be, I can describe the slope of the line. Is it positive or negative? If it's no slope, or is it undefined? And can I find the slope of a line given a graph or a table? So those are the two things we got to look at today. So the big thing we're going to talk about here is slope. What is it? And a slope, you guys, is a number. Number one, it's just a number, okay? And it's essentially, what it is, it's the steepness of a line, okay? And if you ever have an appreciation for slope, think of the steps. The steps of any stairs should have the same slope, whether you're going up or down, because if it didn't, you'd be tripping up those stairs, right? So really important slope in everyday life, but it's the steepness of a line, but it's just a number. So the slope m of a line is a ratio, it's a fraction. And it's represented by the change in y, that's the rise, how much you're going up or down, to the change in x, the run, how much are you moving left and right between any 2 points on the line. So it doesn't matter which 2 points you choose, so long as they're on the line, you're going to get the same slope. And so they give you this nifty little formula here, which is really important to remember, okay? And the last little thing here is actually the equation that we use most often here to find the slope, okay? So that's the really important piece right there that I just highlighted. So it's the slope is the steepness of a line, and if you look down here, you can get it from a graph just by counting. You can either go run first and up, but it's usually we go rise over run, and you just count. How much do we move left and right? How much do we get up and down to go from one point to the other? So it's very much like translations that we did when we did transformations in our last unit. So there really are 4 types of slopes you can have, and we actually have just 2 of them here. The line rises from left to right. So when you look at this picture here, it looks like when it rises, it's going up from left to right. I just consider that when you're just going uphill. When you have to go uphill, it's a positive slope, okay? When the line falls, okay, you're downhill like you're skiing, okay, that's downhill, right? Skiers want to have negative slopes. You don't want to be skiing uphill. If you guys hear anything in the background, that's just my wife. She's scooping up some cake that I'm going to also have to record this video. So I'm pretty excited about that. So while you guys are taking notes on this, I'm probably going to be stopping and eating cake. So let's look at the slope of a line. So here are 2 lines here, and you can see on the left that the one on the left here is going to fall. It's going downhill. So our slope m should be negative. Okay, so make a note of that. It's got to be a negative slope, so my answer better be negative. So I'm back. Cake was delicious. Okay, so the slope here is negative. Now, according to our formula, you're going to want to use m equals y2 minus y1 over x2 minus x1. But if you're given a graph, you don't need to use this. If I'm given a graph, watch. So I need to go from point A to point B. And so this slope is negative, so I'm going to count 1, 2, 3 down. So I'm going to draw my line down. Okay, and that's minus 3 units. I go 3 units down. And then I'm going to see how far do I have to go left or right, the run. So I go 1, it's just like 2 spots, okay? So my change y2 minus y1 was negative 3. It went down 3 units, okay? And I went to the right 2. And it doesn't matter which direction I go, okay? For example, if I just switch this process, so these 2 different colors, if I go up 1, 2, 3, so that's up 3, so plus 3 now, from this point to that point, and then I would go left. I'm going left 2, so that would be negative 2. So you would still have negative 3 halves. The negative would be with the 2, but that's okay. It's the same process. So yes, we use m equals y2 minus y1 over x2 minus x1. So how that would look, let's just consider this point number 1, this point number 2. So my y2 would be this value right here, this negative 2, minus my y1 value is right there, it's a 1, over my x2 value, which is 1, minus negative 1. Notice how I put in parentheses negative 1. They're not the same negative there. So you would have negative 2 minus 1, which is negative 3, and 1 minus negative 1. That becomes plus 1. So that's negative 3/2. So there's three ways to do the same problem. But if you're given a graph, just count. Just count. It's the easiest thing to do. Okay, so in example 2 here, my slope is still y2 minus y1. I'm going to write that again so we get in the habit of knowing how we calculate the slope. So we're at y2 minus y1 over x2 minus x1. So let's just do the rise. So I'm going to go up. Okay, and that was up 1, 2, 3, 4, 5 to get on that same level. Up 5, so it's positive. And I'm going to run now. I'm going to go to the right. Moving to the right is positive direction. So right 1, 2, 3, 4, 5, 6 plus 6. So my slope ends up being 5 over 6. And that's how you find the slope from a graph. Okay? Now, could we plug those points in? Absolutely. I'll do that too, just to be safe. Let's just call this point 1, point 2. Okay? So y2 is 4. y1 is negative 1. Put it in parentheses. x2, which is 3, minus negative 3. So that again, that is subtracting a negative, that becomes positive. Subtracting a negative becomes positive, and there's 5, 6. Okay, so that's how you find the slope of a line from a graph. If you have any questions, please let me know. We'll see you next time.